Okay, good morning to all of you. I welcome you all. Today we are going to see the problems in the topic of equilibrium of rigid body. In last class, we see the solving procedure. We see the solving procedure to solve the equilibrium of rigid bodies and find out the reaction forces at the point of contact. Here we are going to see the another example. So the problem here is two smooth pipes each having a mass of that 300 kg are supported by the forked tines of the tractor shown in figure. So draw the free body diagram for each pipe and both pipe together. So here the problem is the two smooth pipes each having a mass of 300 kg are supported by the forked tines of the tractor. So here the tractor, the two smooth pipes. Smooth pipe means we ignore the friction, ignore the surface friction. So each having a mass, so mass value given are supported by the forked tines of the tractor. So here like the V channel. So draw the free body diagram for each pipe and both pipe together. In addition to the problem, we are also going to find out the reaction forces at the point of contact. Here the pipe 2, here the pipe A is contact with the V channel or forked tines of the tractor at point here and there. And the two pipes are also in direct physical contact and the pipe B is also in contact with the forked tines of the tractor. So here in this problem we are going to draw the free body diagram of each smooth pipe. In addition also find the reactions at the point of contact. Here the contact is C and O is the point. We assume at the point we place the rectangular coordinate system. Point D. Point D is the contact point between the pipe A and pipe D. And point E is the contact point between the pipe and forked liner. So this is the problem. We are going to draw the free body diagram. The free body diagram means the body is free from its surrounding and apply all the known force and unknown force acting on it. So here the pipe A. This is the free body diagram of the pipe A. That means we separate the system from the surrounding. This is the surrounding. This is the surrounding. We separate the pipe A from the surrounding. It is the free body diagram of A and apply all the known forces. Here the weight of the pipe always acting to the center of gravity. So this is the center of gravity point. So the weight force is always acting vertically downward through the center of gravity. So second, the T means here the reaction force. It is the force exerted by the fork liner on the pipe A. Next is the another force F. Here also the reaction force. The reaction force acts on the pipe due to the contact between the forked liner and the pipe. The another reaction force here R is the pipe P. Apply the reaction force on the pipe P. So this is the free body diagram of pipe A and pipe B. Pipe B also we place the rectangular coordinate system and apply the known and unknown forces. Here the known force is the weight force. The weight force always acting through the center of gravity and the reaction force at point E. So the reaction force, we draw the reaction force at the point and the another reaction force. This reaction force is generated due to the contact between the pipe A and pipe B. This force applied by the pipe A. Here Here I draw the free body diagram. Just RC means the reaction force at point C, or reaction C at point C. Here this is the contact point C. This is the contact point D. At the point, the forked tiner apply the reaction force on the pipe. So RD, reaction force at D. Here the reaction force at E. This is the E point. At E point, the fork apply the reaction force on the pipe. This point is G. This point is G. At G point, two reaction forces R2 it is the reaction force applied by the pipe 2 on pipe E1, or applied by the pipe B on pipe A. Here R1 is the reaction force applied by the pipe A on pipe B. This is the mutual reaction forces, same magnitude and opposite direction. So here R2 equal to R1 equal to R, same magnitude and opposite direction, mutual action and reaction forces. Here we are going to find the angle between the line of action of force and coordinate system. First here point O and point E. So point is the contact point between the pipe B and forked liner. Okay. Then so we use the point O E. This line is called line of action of reaction force RE. So we use the line of action of reaction force RE and one of the surface of the V groove or tractor and the x-axis coordinate system placed at point O. We use the point O, E and line of action of force. We construct the right angle triangle O, E, F. Construct the right angle triangle. Here the theta is already given. Here 90 degree. Summation of all the angle in the right angle triangle is equal to 180 degree. So the remaining angle is 60 degree. So here the another triangle, we form the another triangle using the point O2. This is the line of action of weight force. This is the line of action of weight force, and this is the line of action of reaction force RE and the coordinate system X. Using these two line of action of forces and horizontal force, we form the another right angle triangle O2HF. Here 90 degree, here 60 degree, here find the 30 degree. Using the trigonometry, basic trigonometries, to calculate the angle between the forces under the coordinate system. Here pipe B. Here pipe B, three forces are acting on the pipe. One is the weight force. Weight force always vertically downward. We place the coordinate system at center of the pipe B. So x-axis, y-axis. So weight force always vertically downward. R1 is the reaction force applied by the pipe A. So angle 30 degree. So angle 30 degree means the R1 is parallel. The line of action of R1 is parallel to the V groove surface, one of the V groove surface. So the V groove surface is inclined at angle 30 degree to the horizontal surface. So we use the basic trigonometry to find the 30 degree. And the RE, we use the previous trigonometry to find the angle 30 degree. So this is force is based on the principle of transformability, force is the sliding vector. So we shift to the vector without change its direction and magnitude. So shift to the RE. So shift the RE to here, then same shift the R1 to point O. So we use the Lami's theorem and find out the reaction R1 and RE. We know the weight force. So this is the Lami's theorem. We equate any two terms and find out the RE and R1. Okay, this is the free body diagram. This is the free body diagram of pipe A. Pipe A, this is the weight force. So pipe A center point is O1. We place the rectangular coordinate system at O1, X and Y. Then weight force and apply all the known forces acting on it. Weight force 2943 Newton, and weight force always vertically downward. Next, the reaction force RC. So reaction force RC. So the direction of the reaction force is, we find from the direction of the reaction force RC. It is parallel to this reaction. So this reaction force is parallel to one of the surfaces of the tractor or V group surface. So we use the same angle, 30 degree. We use the basic mathematical trigonometry to find the 30 degree. And this is the R2. R2 means the reaction force applied by the pipe B on pipe A. So this is the pipe A section. And RD, the reaction force at contact point D. So here for 30 degree, we find 30 degree from the basic trigonometric equation. The same procedure from the pipe B. So pipe B, we construct the two right angle triangle and find out the angle between the reaction forces and coordinate axis minus 1. We use the same step to find the angle here, 30 degree. So here more than 3 forces acting on it. We apply the equilibrium of equations, two-dimensional equilibrium of equations, and we find out the two unknown forces. So two equations, sum of horizontal force equal to 0, sum of vertical force equal to 0. So two equation, two unknown, only RC and RD is unknown. Here R2 is equal to R1, R1 equal to R. So we substitute the value and find the X and Y component. We use the two equations to find the unknowns RC and RD. Thank you.